angle, side, angle. So we're looking at the kind of the lower left on the top
Hmm.
right. There are additional things that you can prove here, but is this angle, side, angle? Do you have an angle, a side, and another angle?
Yeah.
You do if you add in this one.
Hmm. Yeah.
We can say check for that. Now, let's go. I'm going to grab this one more. Now let's look at angle, angle, side. Got to be careful with this one. The direction does matter. What do you think here?
I think
Do you,
it's angle side angle. If you turn the 90
well, that's
degree
yeah,
angles.
but that's what we're talking about. Angle, angle, and then do you have the next side? So you have the angle, the vertical angle, then you
Hmm.
have the 90-degree angle, and then do you
Yeah.
have the side there? Yes,
Yeah.
this one does work. Okay, let's go to the next one here, which is hypotenuse leg. So it's pretty simple. You have to have the hypotenuses congruent. They can't just look congruent. They actually have to be congruent. Are the hypotenuses congruent?
Or the hypotenuse.
Is LM congruent to MQ?
No.
No. Even though they might look it, the answer is no.
Okay, and immediately for number four, it's no.
I agree. Four side, side, side is also no. Okay. All right. So let's look. So five through 10. I mean, this is like there's like one thing they wanted you to know from the first part of the course, like, do you not approve to most congruent? Your list is, side, 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 angle, side, angle, 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 side, or hypotenuse leg.
Mhm.
And the answer could be like, no, they're not congruent. Like, that's okay too. So,
Yeah,
are these
no, it's
congruent?
not.
So, we do have a side, but do we have an angle? Are there any angles that you can prove are congruent? And you're correct. It is no. All right. So, tell me about this one. What do you see? Do you see enough here to prove congruence? And with so, which one?
Well, there's two angles inside.
Okay. Which of those letter groupings is it?
I'd say it's a angle side.
You are correct. Very good. All right, number 7. All right, what do you see here?
Well, there's two angles here, but you see the T to the U?
Yep.
That's a side.
Is that congruent?
Mm-hmm.
Why is it congruent?
They congruent. It's just just a side in the middle.
We have to use better language than that. Do you remember any words when they're shared? What the word is when they're identical?
Um, is
When
it
you look in
would
the
it?
mirror, you see yourself. What do you
Oh,
call
it's a
that?
reflection.
Yes. So the
Reflection.
reflexive. Now, I'm not big on names, but I think it's important to know that. So yeah, that side is congruent. So which postulate theorem are you using?
Postulate. It's I'd say it's angle side angle because that's the
You got it. Yeah. That's the most important part. Like congruent, okay, great. Which one, that's 80% is to know which one it is. All right. Number 8 here. What do you say? What do you say?
Can't be any of the angles or the sides and the.
It's important to recognize what kind of triangle is this.
Oh, that's it's right angle.
Not always, but it's a good one to go to. Is it hypotenuse leg? Are the hypotenuses congruent? And then do you have a leg congruent? Same
I
leg.
I'd say yes, yes. There.
This one is the hypotenuse is the same, so yes, it does work. All right, number 9 requires you to focus on parallel lines and what that means as far as like stuff that's congruent.
Mhm. So I'd say that in the middle, those are the T. I forget what it's called, but the
Vertical
angles.
angles. Yep,
Mhm.
vertical angles.
Also, V and S, those are congruent.
What's the reason for that?
They're vertical angles. I forget.
They're not vertical. The vertical angles meet at an X. It's the two parallel lines cut by a transversal. What region
Uh,
of the what region are they in?
they're in the interior.
Interior, and they what over the transversal? There's a word where you sort of flop over, switch over,
They're
alternate interior angles.
alternate. I'll write that. All right.
That's a good way to show work. It does say to explain your reasoning. All right. So now that we've done all that, though, are they congruent? And if so, which one is it?
I would say it's still on number. Yeah,
We're still
I'd
on number
say it's
9. Yeah.
angle
Sorry about
side
that.
angle. Sorry, I thought you moved to number
So
10.
for this one to be true, the side that's congruent has to be between the angles.
Mm-hmm.
Is that the case? The way we've
Yeah.
drawn it?
Yes.
Well, okay.
Oh wait, we're missing one. I forgot.
Like it is if you use the other alternate interior angle one, but we haven't drawn that yet.
Yeah, sorry, I forgot about R and U.
So like it's well, it depends. The one that you could have used was angle side, based on what you told me, and then ASA is also true if you do the other one. Prove the other one.
Mm-hmm. So it's
All right. Any questions on
oh
that?
no, no questions.
All right. Number 10. All 3 angles are congruent. Maybe something else is.
The wait, the
What
J
do
and
you see?
L, that line, those are that's a side.
Okay. So what congruence are you going to use?
I think it would be angle side angle.
I agree. Angle side angle. All right. And your final is actually like in person or was this
No,
part of it?
the my finals, I think it's just on a piece of paper or on a computer. I don't know.
Is
Definitely in
it
person.
online or on paper?
No, it's in person. I'm still on.
Okay. All right. All right. Let's look at number 11 now. All right. See if we can make some progress here. So, okay, it says line AC, it's actually a line segment, bisects angle BAD. So that means that the this angle is congruent to this angle down here. Is it possible to prove that triangle ABC is congruent, I assume, to the other one? So
Mhm.
is that enough? Okay.
Mhm.
So what else? do you see here that is congruent?
The C right here is that both sides are also
Give me C is
equal.
not a side. Give me two letters for a side.
Oh, AC.
Okay, so we got that. So what theorem are we using to prove this, if any?
Um, Angle side angle is that?
Okay, what's the other angle that's congruent?
Oh, the BC, uh, DC. I forget what it's called, but the other side. There's
Okay,
like
how
two
do you,
angles at the other side. Like A,
right?
that's
So
that same
which,
thing at the C.
but that's not given. Like it just says AC is bisecting BAD. Oh,
Hmm.
and angle BCD. Okay, see, there we go. I didn't see that. Yeah, and those angles are bisected. Yes, so now it is angle side angle. All right, number 12 is a proof. So fill in the blank proof. All right. Usually the first statement is given. They didn't really even give you anything here, but we're gonna presume that this is given. All right. So it's good to mark up the drawing here. BAC. It's kind of hard to see here. So let me switch. Yeah, PDF. It's this one and this one. Those are congruent. Maybe easier to see. Okay. And then BA, that's this line right here is congruent to this one right here.
Hmm.
What letters go in this position? What goes here?
I'd say ED. ED.
ED. All right, good. And then I guess three is given. It's like you're missing something to be able to do this. Like usually they give you a list of givens. Is there anything else that goes along with this?
Huh.
Okay, so we're gonna go with that. This is given as well. I mean, it's in the drawing, so that's reasonable that it was given. So they're telling you that DEF, which you already know, D to E to F, this one here in the bottom, that's a right angle. And what's the other one in the other triangle? That's a right angle. What's the three letters we could use there?
Huh. DEF. Let's see.
What's the right?
How about ABC?
ABC will do. Okay, so this is now more like the problem we were doing. They're saying the triangles are congruent. What is the reasoning? You know, is it SSS, SAS, you know, AS, what's the reasoning here?
Hmm. I'd say angle side angle.
It's very good. All right, so that is it for proofs. Um,
Hmm.
I guess we'll just do these in order. I was going to suggest maybe moving to a different problem, but we'll go to 13. All right, to calculate the length of the marsh, a surveyor produced the following diagram. Find the length of the marsh to the nearest tenth of a unit. So they want you to find, I'm going to call it L, I guess. Um, you can set up a proportion to solve this. And you remember the way we were doing it the other day? It's last week. You know, you could look at the like one on the left of is a triangle, the one on the right is a triangle, or the top is a triangle, the bottom is a triangle. Will you attempt to set this up? You know, there's only four things, so there I'm gonna go in some positions here, and
Uh,
we'll.
yeah. Is that supposed to be an L right there at the top?
Yeah, if you don't like L, we can use X. I mean,
Yeah, I'll just use X.
X is fine.
So X over 18.6.
Right. So here's what you're saying. X is
And
the longer leg, and that's the shorter leg.
uh-huh.
So match that up over here on the right.
All right, so then it would be 16.2
Okay,
over 3.6.
good. Okay, so to solve this, you have to, I mean, a few things you could do, or you can diagonally multiply 3.6 times X equals 18.6 times 16.2. And
Mm-hmm.
then get that number, divide by 3.6. Let me know what you come up with, please.
The answer?
Yes, please.
All right. Yeah, I got 8, X equals 8, 83.7. 83.7.
Um, Sounds right. Okay, good. And then we need units. We should add in the units there. Okay, we're gonna do 15 first because the picture's already there. And then that'll kind of lead to how to do 14. Um, it's usually easier if there's a picture. So there's actually two triangles here. There's the small one and there's the large one. So this is 3 and this is 2. This is 30. This is H. Could you
Mm-hmm.
set up a proportion here? Or maybe you already know the answer.
See, so H over 30 equals 2 over 3.
Like that. Okay, you want to solve that for H for us, please?
Yep. Okay, so I got H equals 20.
20 meters. Yeah, perfect. All right, so 14 is really similar. You could actually, actually reuse, whoa, why is that doing that? You could actually reuse like some of the drawings that you had before, but the smaller one is the telephone pole, and then the larger one is the tree. So it's 10-meter tall telephone pole, eight 8-meter shadow. Nearby tree casts a shadow that's 14.
Mm-hmm.
So set up a proportion there and see if you can solve that for the given value.
Do we have enough time?
It's up to you. I mean, we're closing down here on that. I'll
Wait, hold on. I don't think I have that on my paper. 14?
I did them out of order, by the way. I did 15 first, so that's okay. We'll just pick up here, even we redo this one next time, that's fine. So all right.